Hello grade 8 math students. We are now on week 8 quarter 3 of mathematics 8. I am your teacher for today, Teacher Dan. In this lesson, we are expected to number 1, use the concept of angle bisector to prove triangle congruence. Number 2, use the concept of perpendicular lines to prove triangle congruence, especially congruence for right triangle. Before we continue, let us first review what an angle bisector is. In the past lesson, we learned that angle bisector is a line, a ray, or a segment that divides an angle into two equal angles. What about a bisector of a segment? If an angle bisector divides the angle into two congruent angles, then therefore, bisector of the segment is a line, a ray, or a segment that divides a segment into two equal parts. Okay, let us move on to what perpendicular lines are. Perpendicular lines are lines that intersect, forming a right angle or a 90-degree angle. Let us now put the concept together and talk about perpendicular bisector of a segment. Having learned that perpendicular lines form right angles and that the bisector of a segment divides a segment into two congruent segments, then therefore a perpendicular bisector of a segment is a ray that is perpendicular to the line segment and divides the segment into two congruent parts. So from this, you can now distinguish the difference between an angle bisector from a perpendicular bisector of a segment. So if that is the case, let us now proceed to our lesson. Our lesson is apply triangle congruence to construct perpendicular lines and angle bisector. Before we continue, I want you to look at this picture. Do you like what is in the picture? If you are asked to describe or write a very simple paragraph about the picture, what would it be? Let us now have activity number 1. This is about the perpendicular bisector theorem. The theorem states that if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoint of the segment. Let us first illustrate the if-then statement. Let us draw segment AC and the bisector of segment AC, which is line BD. So from our illustration, we can now write the given. The given, we have line segment BD is the perpendicular bisector of segment AC. We need to prove that segment AB is congruent to segment BC. So having now the given statement and the proof statement, we can now start the two-column proof. As usual, we will have the statements in the first column and the reason for every statement on the second column. As always, our first statement is the given, which is segment BD is the perpendicular bisector of segment AC. And the reason is given. If BD is the perpendicular bisector of AC, what conclusion can we make? Of course, we can deduce the following statement. We can have segment AD is congruent to segment CD. And angle ADB and angle CDB are right angles. The reason is definition of perpendicular bisector of a segment. Okay, next. If angle ADB and angle CDB are right angles, then we can say that they are congruent. And the reason is all right angles are congruent. Then we can now draw segment AB and segment BC because 2 points determine a line or simply by construction. So what do we have now? We have now one big triangle, triangle ABC, and two smaller triangles. We can have triangle ADB and triangle CDB, the two smaller triangles. Do you think that these two triangles are congruent? Based on the given markings, still insufficient to say that the two smaller triangles are congruent. Okay, but what can you say about segment BD? Of course, by reflexivity, segment BD is congruent to segment BD. Then, triangle ADB is congruent now to triangle CDB. By what congruence postulate? Okay, by SAS congruence postulate. In this case, we can now say that segment AB is congruent to segment BC because corresponding parts of congruent triangles are congruent. So that would be our reason, or the CPCTC. Okay? Okay, let's now move on to activity number 2. Let us now prove the next theorem, the angle bisector theorem, which states that every point in the bisector of an angle is equidistant from the sides of the angle. So let us illustrate the first theorem. Of course, it talks about an angle and its bisector. So we can have angle ABC first and ray BD being its bisector. Then we construct segment AD perpendicular to segment AB. And segment DC perpendicular to segment BC. Okay, what we will prove is that segment AD is congruent to segment DC or CD. Okay, let us now have two-column proof. Okay, we have the statement in the first column and the reason for the second column. Again, we can start our statements from the given. Segment BD bisects angle ABC, and then we have AD perpendicular to AB, DC perpendicular to BC. The reason is given. Let us now deduce the next statement from this. Okay, from the given statement, we can say that angle ABD is congruent to angle CBD. The reason is definition of angle bisector. Also, we can say that angle BAD and angle BCD are right angles. So the reason is definition of perpendicular lines. Okay, if angle BAD and angle BCD are right angles, then we can say that they are congruent. So our reason is all right angles are congruent. Segment BD congruent to segment BD by reflexive property. Now, try marking the congruent parts of the triangle. Triangle BAD and triangle BCD. Okay. Can we already say that they are congruent? Yes, we have now triangle BAD is congruent to triangle BCD. By what congruence postulate? Since we have an angle another angle, and a side congruent to the corresponding angle, and a side of the other triangle. So they are congruent by AAS postulate or by hypotenuse acute angle theorem. Okay? Next, we can now say that segment AD is congruent to segment CD by CPCTC, or corresponding parts of congruent triangles are congruent. For our practice exercise, given this figure, segment ED is the perpendicular bisector of triangle BES. You are asked to prove segment BE congruent to segment SE. And for the second figure, given segment OE bisects angle E, segment OL perpendicular to segment LE, segment OV perpendicular to segment VE, and you are asked to prove segment LE congruent to segment VE. And for our summary, perpendicular bisector theorem: if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoint of the segment. Angle bisector theorem: every point on the bisector of an angle is equidistant from the sides of the angle. Okay, going back to this picture, how will you relate this picture to our lesson? Okay, think about it. And for your assignment, you are to write and prove the converse of the perpendicular bisector theorem. That's all for today. Thank you and God bless.